Hello students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. In application of partial derivatives, today's topic is local extreme values. So in local extreme values, I will teach you how to find out the maximum or minimum value of a two variable function. So let's start. Now we have a working rule to determine the maximum and minimum value of a function f of x comma y. So first of all, what we have to do, we have to find out del f by del x, and we have to equate with it 0 and say that is equation number 1. Then after we will find out del f by del y and we will equate it to 0 and say that is equation number 2. And then after points obtained from solving equation 1 and 2 are called stationary points. Then after we have to find out the values of r, s and t, where r is del square f by del x square, s is del square f by del x del y, and t is del square f by del y square. Now we will find out the value of RT minus S square. Now based on the sign of RT minus S square, we will decide whether we will be having a maximum or minimum value of a function. So we have total three conditions. One is RT minus S square is greater than 0. If RT minus S square is greater than 0, then there will be a maximum or minimum value of a given function. So in that case, how do we judge whether the function will be having maximum value or minimum value? If r is less than 0 or t is less than 0, then the function will become maximum. And if r is greater than 0 or t is greater than 0, then the function will be minimum. And if rt minus s square is less than 0, then there will be no maxima or minima, and the point that is called saddle points. And if rt minus s square is 0, then there will be no conclusion. Now this is the process through which we can find out the maximum or minimum value of a given function. Now we will see example related to this topic. Example number 1 is find the extreme values of the function x cubed plus 3xy square minus 3x square minus 3y square plus 4 if any. So here function of xy is x cubed plus 3xy square minus 3x square minus 3y square plus 4. So first of all, for extreme values, we will find out del f by del x and then after we will equate it to 0. And del f by del x, that is nothing but the partial derivative of function of xy with respect to x keeping y constant. So derivative of x cube is 3x square according to the formula dy dx x raised to n, that is equals to n into x raised to n minus 1. Then after 3y square is constant and derivative of x is 1, and if you will multiply 3y square by 1, the result is 3y square. Then after derivative of x square is 2x, now multiply 2x by 3, so that is 6x. Then after minus 3y square and plus 4 are constant value, so its derivative will be 0. Now we will divide this equation by 3. So we have x square plus y square minus 2x, that is equals to 0. Now say this is equation number 1. Now we will find out del f by del y and then after we will equate that result to 0. and del f by del y, that is nothing but the partial derivative of function of xy with respect to y. So we have to keep x constant. So x cube is constant, so its derivative is 0. Then after 3x is constant and derivative of y square is 2y, and 2y into 3x, answer is 6xy. Then after minus 3x square is constant and its derivative will be 0. Then after minus 3 will be constant value and derivative of y square is 2y. Now multiply minus 3 by 2y, so it will become minus 6y, and 4 is a constant value, so its derivative will be 0. So we have 6xy minus 6y equals to 0. So this is del f by del y. Now taking 6y common, so we have 6y into bracket x minus 1 equals to 0. Now we will equate 6y to 0 and x minus 1 to 0. So we have value of y equals to 0 and x equals to 1. Now putting the value of y equals to 0 in equation 1. So equation number 1 is x square plus y square minus 2x equals to 0. In this equation we will put the value of y equals to 0. So x square will be as it is. The value of y square, it will become 0, as 0 square is 0. Then after minus 2x will be as it is, and that is equals to 0. Now from here we will find out the values of x. So taking x common, so into bracket we have x minus 2 and this is equals to 0. Now from here we have x equals to 0 and x equals to 2. Now for y equals to 0 we have x equals to 0, and for y equals to 0 we have x equals to 2. So the stationary points are 0, 0 and 2, 0. Now putting x equals to 1 in equation 1. Equation 1 is x square plus y square minus 2x equals to 0. So replacing x by 1, so it is 1 square, that is 1, plus y square, and minus 2 into 1, result is minus 2, and this is equals to 0. So 1 minus 2, answer is minus 1. So y square minus 1 equals to 0. So we have 1 plus y square minus 2 equals to 0. So we have y square minus 1 equals to 0, as 1 minus 2 is minus 1. Now from here we will find out the value of y, that is y equals to 1 or y equals to minus 1. Now the stationary points are, for x equals to 1 we have y equals to 1. So one point is 1 comma 1, and for x equals to 1 we have y equals to minus 1. So the other point is 1 comma minus 1. So total we have 4 stationary points. Now we will find out r, s and t. R, that is nothing but del square f by del x square. Del square f by del x square, that is nothing but the partial derivative of del f by del x with respect to x. Now you can see that del f by del x is 3x square plus 3y square minus 6x. Now we will partially differentiate this equation with respect to x. So derivative of x square is 2x. 2x into 3, answer is 6x. Then after 3y square is a constant value, its derivative will be 0. Then after minus 6 will be as it is, and derivative of x with respect to x, answer is 1. So 6 into 1, answer is 6. So r equals to 6x minus 6. Now we will find out s, that is equals to del square f by del x del y, and del square f by del x del y, that is nothing but the partial derivative of del f by del y with respect to x, and we have del f by del y, that is equals to 6xy minus 6y. Now we will differentiate partially del f by del y with respect to x. So we will keep y constant. So 6y is constant and derivative of x is 1. So 6y into 1, answer is 6y. Then after minus 6y is constant, so its derivative will be 0. So we have s equals to 6y. Now we will find out t, and t, that is nothing but del square f by del y square, and del square f by del y square, that is nothing but partial derivative of del f by del y with respect to y. and we have lf by del y that is equal to 6xy minus 6y. Now we will differentiate this equation partially with respect to y. So we will keep x constant. So 6x is constant and derivative of y with respect to y, that is 1. So 6x into 1, answer is 6x. Then after minus 6 will be constant and derivative of y with respect to y, that is 1. So it is 6 into 1, that is 6. So we have t that is equal to 6x minus 6. Now we have r equals to 6x minus 6, s equals to 6y, and t equals to 6x minus 6. Now we will find out the value of rt minus s square. So we will take all the stationary points. So first of all, for the stationary point 0 comma 0, for this 0 comma 0 point, we will find out the value of r s t. Then after rt minus s square, and based on rt minus s square and the sign of r, we will conclude whether the function will be having maximum value or minimum value, or it will be a saddle point. So for the point 0 comma 0, x is 0 and y is 0, and r equals to 6x minus 6. So here if we will put the value of x equals to 0, so it will become minus 6. The value of r is minus 6 and it is less than 0. And for s, if we will put down the value of y equals to 0 over here, so it will become 0. So the value of s is 0. Now value of t, replacing x by 0, so it will become minus 6. So value of t is minus 6. Now we will find out rt minus s square. So minus 6 into minus 6, that is 36, and s is 0. So 36 minus 0, that is 36, and 36 is positive, and the value of r is minus 6, and which is negative. So we will be having maximum value of given function of fxy at point 0, 0. Now similarly we will repeat this process for the remaining three stationary points. Now for point 2 comma 0, we will replace x by 2. So r is 6 into 2, 12, and 12 minus 6 is 6. So the value of r is positive, and for s replacing y by 0. So it is 6 into 0, so that is 0, and for t replacing x by 2, so 6 into 2, 12, 12 minus 6 is 6, the value of t is 6. Now rt minus s square, 6 6 they are 36 minus 0, so it is 36 and it is positive, and the value of r is 6 which is positive, so we will be having minimum value. Now put the point 1 comma 1, replacing x by 1, so 6 minus 6 is 0, replacing y by 1, so we have s equals to 6 into 1, so that is 6, and for t replacing x by 1, so it is 6 into 1, 6 minus 6, so that is 0. Now rt minus s square, 0 into 0, 0, minus x square is 36, so it will become minus 36 less than 0. Here rt minus s square is negative, so we won't have maximum or minimum value of given function at point 1 1, and this point is called saddle point. Now for the remaining stationary point 1 comma minus 1, replacing x by 1 in r, so 6 into 1 6, 6 minus 6 is 0. For s equals to 6y, replacing y by minus 1, so s equals to 6 into minus 1, so that is minus 6. And for t, replacing x by 1, so 6 into 1 6, 6 minus 6 is 0, so value of t is 0. Now rt minus s square, that will be 0 into 0 minus 6 square, so it will become minus 36. So again we have minus 36 is less than 0. So we want to have maximum or minimum value of a given function at point 1 comma minus 1. So this point is called saddle point. Now we will find out the maximum value of a given function at point 0, 0, and the minimum value of a given function at 2 comma 0. Here fxy is maximum at 0 comma 0 and minimum at 2 comma 0. and given function fxy is x cube plus 3xy square minus 3x square minus 3y square plus 4. So f maximum at 0, 0, in this function we will replace x by 0 and y by 0. So the first term, second term, third term and fourth term will become 0, and 4 is constant, so it will remain same. So 0 plus 4, answer is 4. So this is the maximum value of given function at point 0, 0. Now f of xy is x cube plus 3xy square minus 3x square minus 3y square plus 4. Now we will find out the minimum value of a given function at 2, comma 0. So in this function we will replace x by 2 and y by 0. So it is 2 cube plus 3 into 2 into 0 square minus 3 into 2 square minus 3 into 0 square plus 4. And 2 cube is 8, and if you multiply 0 by any value, the result is 0. 2 square is 4, 4 into 3 is 12, so it is minus 12. And if you multiply 3 by 0, so it will become 0, plus 4 will be as it is. Now we will simplify this result. You can see plus 8 plus 4, that is plus 12, and plus 12 minus 12 will cancel out. So the minimum value of the given function at point 2 comma 0, that is 0. So this is all about the maxima or minimum value of given function. So in today's lecture, we have discussed how to find out the maxima or a minima value of two variable function and one example related to this topic. Thank you for watching this video. I will see you in the next lecture.